Hey YouTube, and welcome back. In the last video, we learned some basics about machine learning and how it can be used to build a model that we then use to predict if a patient has a heart disease or not. In this video, we will learn how to apply what we have learned so far into our IoT problem statement. So, here's our problem statement. Francis lives in a two-room apartment with his furry dog Parsons. Unfortunately, Francis does not own a central air conditioning system, but has cooling fans in both rooms. It is summer, and Francis understands that Parsons will need his room cooled during the daytime and on weekends, especially when he is at work. In this exercise, we will design a machine learning of things system for Francis that can learn from his personal room fan settings, which is the Y variables, and then make control predictions based on input from control sensors, which is the X variable, and time settings in his apartment. Okay, cool. Now that's a cool problem statement, and we've talked about it in the previous video, how whenever Francis makes, sets a control, it gets saved in the cloud, right? And when a sensor setting is available, it gets sent to the cloud, and the cloud returns what the appropriate state of the fan should be. We're also going to make some assumptions. In this problem, we will assume that we've already collected the data from Francis's home, which is the data that shows the sensor measurement and target values of the fan that's on or off. Our collected data we are going to host on this Google Sheets doc, right? So you can see the data we've collected, showing time, the period of the day, if it's night, morning, afternoon, right? The weekday, which is Sunday, Monday, Tuesday. I think we only have data for 1 week till Saturday, right? Studio motion. So if there's motion in the room, so we want to know if Francis is in his room. So you can see our motion sensor here, right? And we want to know if Francis is in his room or if Parsons is in his room. Studio temperature, right? We also want to know the temperature of the room. Dog room temperature, which is the temperature, that's the studio temperature, is the temperature of Francis's room, while dog room temperature is the temperature of Parsons's room, right? And then if the studio fan, which is Francis's fan, is on or off, right? So there's some times when it's on, right? Like here we have around 12 in the afternoon on Sunday, both motions in both places. And if Francis was on at 70 degrees, but for some weird reason, Parsons' fan is off. Not sure why. But it's just data, data can never be really accurate. Maybe Francis put on his fan first before he put on Parsons' fan. Probably that's what happened, right? So we have studio fan and dog fan. So this is data that we've already collected. So we are going to host this data in the cloud, right? We're going to use this data to train our machine learning model, and then host our model in our API service, our ML API service, and then that model can then be used to make predictions of what state the fan should be in, depending on what input or sensor input or time input that has been sent to it. Again, our architecture diagram is still the same, right? We have our microcontroller is talking to the MQTT broker, which the data is being collected by the event hub, passes it over to the API service. The API service then uses the ML model to make a prediction and sends the information directly back or through the event hub to the microcontroller. I've taken the time to set up the Colab space, all right? So we have our problem statements. We already know what our question is, and the imports. And then here we load the data like we have discussed earlier. One of the first steps is to gather our historical data, right? Once we've gathered our data, we will need to process it and clean it up, make sure it conforms to what we need to do, right? And then we're going to train the data. Here we train the data in our black box, right? We then validate, make sure everything's okay, we check, make sure and change things and tune things, make sure it's okay. And then we download or we deploy. So let's go ahead and start. So first thing we want to do is to open our data. Now we've made some imports. I think gspread is, we will use gspread to get access to our spreadsheet. So let's do that. So here we are going to authenticate. I'm already logged in as Francis. So I'm just going to use the credential that I used to log into Colab to authenticate. And then I'm going to access this particular spreadsheet, which is what is here, right? And then once I get the spreadsheet, I will then get the values out of the spreadsheet and convert the values into a data frame. So that's pretty much what this open and load, what we need to do in the open and load historical data section. Let's go ahead and see if we can load our data. Okay, make sure our imports are all done. All right, okay, looks like that's done. And now we're going to load this, allow this notebook to access your Google credentials. Yeah, it's using, because I'm logged into Google, so it's going to use my credential. So I'm going to use my email to authenticate. And I'm going to allow that. And now I have the data loaded. All right, so let's just make sure that there's data in here. So I'm going to add the code and I'm just going to print out the data frame, right? So once I print that out, you can see it's loaded all the data: time, period, day, studio motion, dog motion, studio temp, dog temp, studio fan, dog fan, right? So that's all the data that's in here. So it's loaded it already. So that's good. Now you can try this also. The data is available. The spreadsheet is open. As long as you have the link, you can read or view the data. Rather, you can't make edits to it, but you can view it. All right, so you can use the same data if you wanted to. So I'm gonna close that out, and now let's do some processing on the data and some cleanup, right, on our data. So let's go ahead and do this. I'm gonna add some code to that. And here's what we're doing. We're trying to give numbers because we're using a classifier. We need to use, we need to represent things in a way where that the classifier would understand what we're working with, right? So here we have our weekday map. So we're going to map the days. Sunday to 0, Monday to 1, Tuesday to 2. And anything that's true or false, we're going to use 0 as false and 1 as true. And here we have anything that's on or off. We're going to use 0 as on, 0 as off, sorry, and 1 as on. And here we're just going to convert our time to seconds and just save that. All right, so we're going to apply all that data. And now once we have all that done, let's look at what our data frame has become, right? Okay, so you could see, oh, sorry, we didn't run this yet. So let's run this, and now let's run this. So our data frame has changed, right? So the reason why we didn't deal with period is because we're not going to be using period. It's one of the things that when we talk about clean and process data, some data you might not really need and others you would need. So you can do some selections while you're cleaning and processing and figure out what you need and what you don't need, right? So we have this in seconds, 12 midnight starting at 0 and then going up, and up as it goes, right? And then we have the days. Sunday is 0, right? Monday 1 and Saturday 6. We have the motion, if there's motion or not, that's true or false, right? So 1 or 0s. Same here. We have the temperature, we have the numbers for the temperature in Fahrenheit. we have the studio fan or dog fan that's on off, which will be zeros or ones. Okay, this is looking good. So now that we've processed our data, I think we still have some more processing to do. So let's separate our data. And for this particular problem, we'll be creating two different models. One to predict the studio fan and the other to predict the dog fan. We could have one model do the prediction technically, but to simplify this problem, because many of us watching this video might be new to machine learning, we would create two models, one to predict the studio fan and the other to predict the dog fan, right? So let's go ahead and add some code for that. Now we have our studio data different from our dog data, and just to test that, so let's print out our studio data. Right, so now you can see it's just time, day, studio motion, studio temperature, and studio fan. So we have all the information we need for the studio. And the same thing will be for the dog fan. We'll have the time, the day, the dog motion, dog temperature, and dog fan. So we also need to separate our features and targets, right? Our X and our Y's. I don't think we've done that yet. We will do that first. Then after that, we will separate our training data. Let's go ahead and do that here. So here we have Y for studio and Y variable for the dog room, right? So that's if the states if the studio fan is on, or the states if the dog fan is on or off, right? And then we have the X for the studio, right? And we have the X for the dog room, right? So now that we have that, we can run that. And now let's go ahead and now split our data, right, into the training and test data. Here we are splitting the data to training, X for the training. We have some X variables that we're going to use for training and some features that we're going to use for test. And we have some targets that we're going to use for training and some targets that we're going to use for test for both the studio and the dog room, right? And now I think the next step is we will now start to train our data. So basically what we're doing here is we're using the random forest classifier, and we're starting with the studio fan model. And now we have some weights here that we assume. We don't have to use class weights. In our previous example, we didn't. And it's just to tune our data to something that we feel is okay. Now, in the tuning, we are giving the temperature more weight than the rest. So temperature has a very high weight. Day also has a high weight. And I think next is the time of the day. Our data is very small also. It doesn't really create a good model for our data because we don't have that much data anyways to go with. Now here we're going to initialize our random forest classifier. And this is where we're training it by fitting it into our model that we've created here. So we fit the data. And then right after that, we will then print the OOB score, which shows us some form of performance for our model, right? So make sure we run this. I don't think we've split the data yet. So now that we've split the data, we will now run this. So OOB score is about 97%, which is good, right? So we just implemented the studio fan, right? So we also need to create a model for the dog fan. Remember, I had mentioned that we will be creating two different models, and that's why we separated the data into studio data and dog room data. All right, so let's go ahead and now create a second model for our dog fan. And here you see we're giving it weights too. The weights are a little different. The time of the day is higher here, right? It gives you a different output. And it seems here the day also has a high weight, but not as much as in the studio room. But this is just fine tuning. This is what we call, and we say it, you can change the numbers, even the random state variables, or the depth. Now here we have about 95% here, right? 0.95 OOB score. We have our two different model, right? We want to validate, and let's say we calculate the accuracy. So we're just gonna add some code for calculating accuracy here, right? So we're gonna use sklan, and we're gonna predict. Remember, we split our data into training and test, right? X-train and X-test. So we use X-train from here to train our classifier, right? Now and we also use that with the Y-train, right? Right here, right? Now here we're gonna do the X-test for studio, right? And the Y test, and we're going to use it to predict. So the test data, we didn't use it for training, because if not, we'll be kind of overfitting in a way. So basically our training data we use for training, and our test data, which is different sets of data, we use for test. Another thing to note here, I think when we were splitting the data, we probably split it and have test size to be 20%. Right, so 0.2. That's just a note. You can do usually between anything less than 30 is fine, but 20 is usually the preferred. 20 or 10 usually the preferred. Right, so now checking for accuracy. You can see the accuracy of the studio is about 96.6% accurate. And the accuracy of the dog fan model is about 95% accurate. If you wanted to see the confusion matrix, let's see. We can add code to plot our confusion matrix. When we do that, we're just creating a plot. Okay, getting the confusion matrix, right? And from that, we get the confusion value, and then we just convert it to percentage. So now that we have the code for our confusion matrix, let's go ahead and run this. Okay, so we can see the percentages. Let's print out the numbers so we can see how the numbers match up, right? So we're going to print the confusion in that method. We'll just print out the name here. And the next one, we're just going to copy some, just print out the name at the top. Just Parsons, just print it out. Okay. All right, so let's run this again and see. Okay, now that looks better. So we can see here that in the current data that we have here for our model, 161 of the data that we have was actually false, and we predicted false, right? 14 of that's about 88.5%. 14 of that data was actually true, and we predicted true. And there were some errors here and there. It's okay, we can't get them all. Our data might just contain a lot of variables when the light is off, so it's probably just better at predicting when it's off, right? So because it's like 88.9%, 95% here, and then only 7% here, so almost 8% here. That's very low. And then here we have, out of 128 data that we put in, like out of the total data that we put in, we have 128 of that data was off, and we predicted off. However, 44 of them was on. 44 was on, and we predicted on. Right, so that's about 70 to 24% ratio. Right, so it's fair, not not good, not a good model, but it's really good at predicting when the lights are off. We could do some tweaking and try to figure things out, but this is just a training video, so we're not gonna go into the details and try to make it better for now. Now, the final part of what we have to do is to download our model. So let's do that. So let's add some code here. This should download our Studio Fan model. And now we need code to download our Dog Fan model. So let's do that. Let's say download. We just downloaded this dog fan model, the chocolate. Right, so we'll run that. Both files have been downloaded. Let's check them out. So we have two models here: our dog fan model, .joblib, our studio fan model, .joblib. So I hope you enjoyed this video. We've gone through a process where we've try to create a model for this particular problem. Now we are going to upload it to the cloud and let our API service use it. I'm gonna stop this video here, and we're probably just gonna continue in another part. So again, please feel free to subscribe, like, comment, and share this video. And now I will see you in the next part. Thank you.